Okay guys, so let's go through a limiting reactant problem together. So let's say that we have this reaction. C2H6 is reacting with oxygen. And so the C2H6 reacts with oxygen to form carbon dioxide and water. And we are told that we have 10 grams of C2H6 and we're adding to that 10 grams of O2. And so now we need to figure out how many grams of CO2 we can make. So the very first thing we do, remember, no matter what, if we are dealing with a limiting reactant, we must have a balanced chemical equation. So we're going to take a look at our equation, and we notice here that we have 2 carbon. So, and over here we only have 1. So we're going to go ahead and we are going to put a 2 in front of our carbon dioxide. That gives me 2 carbons on the right. And then we're going to also take a look and see that we have 6 hydrogens here and only 2 here. So we want to make sure that we have the same number of hydrogens. So we're going to put a 3 here because since 3 times 2 is 6. So now we have 6 hydrogens on both sides. And then we're going to take a look at those oxygens. And over here we've got 2 times 2 or 4 oxygens here. And we have 3 times 1 or 3 oxygens here, which means we have 7 total oxygens on this side. Notice we have an O2, so to make that balance, we would give a coefficient of 7/2. The other option is to multiply everything across by 2, which would give us 2 C2H6 plus 7O2 yields 4 CO2 and 6 H2O. Either of those equations, this guy here or this guy here, either of those will work for what we're about to do. But it is super important that you have it balanced. All right, so another piece of information that we're going to need before we can figure out how many grams of carbon dioxide are going to be formed is we need to know the molecular weights of our reactants as well as the product. So looking at the C2H6, we note that we have 2 carbons. Each carbon from the periodic table weighs 12 grams per mole. So that's 24. And then we have 6 hydrogens. Each of those weighs 1 gram per mole for a total of 6. So C2H6 has a molecular weight of 30 grams per mole. Sorry, got a little bit messy there. Let's go ahead and fix that. Always important to have our units. All right, and then O2, there's 2 oxygens. Each of those is 16 grams per mole, so that makes 32 grams per mole. And then our carbon dioxide, we have 1 carbon at 12 grams per mole, and we have 2 oxygen at 16 grams per mole. So I didn't give myself very much room here. Hold on. There we go. And so then that gives us 12 from the carbon, 32 from the oxygen, and so we end up with 44 grams per mole for CO2. Okay, so now that we have a balanced chemical equation and we have figured out the molar masses of the reactants and then the product that we're interested in, now we can go about figuring out which of the 2 reactants is the limiting reactant. So we're going to start with our C2H6, and so we were told that we are given 10 grams, and we're going to do it as 10 grams of C2H6. And so what we'll do is we will start with that and we'll just assume all of that gets used up. So if that is true, then we need to go from our grams. The first step is to convert that into moles of C2H6. And we already know that that weighs 30 grams for 1 mole. And so now these grams will cancel because that's gram of C2H6. All right, and then we will use the mole ratio from our balanced chemical equation to get rid of moles of C2H6. So we got 2 C2H6. We got that from our balanced chemical equation. And on top we put 4 moles of CO2. And then if we want to know the mass of CO2, we can use its molar mass, and we know that 44 grams of CO2 will make up 1 mole of CO2. So now our moles of CO2 cancel, and we pull out our handy dandy calculator and we punch in those numbers, and that's going to give us 29 1/3, so 29.3 grams CO2. So that is if all of the C2H6 gets used up. Now we're going to repeat the process. We're going to start all over with our other reactant, which is 10 grams of O2, and we're going to do the same thing. First, we need to convert those grams of O2 into moles of O2, and we've already calculated that 1 mole of O2 weighs 32 grams. And then we need to use the mole ratio between O2 and CO4, which in this case is 7 moles of O2 make 4 moles of CO2. And then we're going to do that last step again where we have 44 grams of CO2. It will make up 1 mole of CO2. So now we cancel out our moles of CO2. And putting that into the calculator, we find that it is 7.86 grams of CO2. So we take a look at those and we notice that this guy is the smaller number. So that means that this is our theoretical yield, because that means that these 10 grams of O2, they get used up first. And so this is our limiting reactant. Okay, and so that blue line, it doesn't even matter for us anymore. The only reason we did that was so that we could compare the two end numbers. So now we know. So now we know that if we started with 10 grams of C2H6 and 10 grams of O2, we know that the 10 grams of O2 is going to get used up first. And once it's used up, the reaction stops. And it will give us a maximum of 7.86 grams of CO2. Now this means if this O2 gets used up first, that means that the C2H6 is in excess. And so we can also figure out how much of that C2H6 gets used up. So we start off with the 10 grams of O2 because that is the limiting reactant. We convert from the moles of O2 from the grams of O2 to the moles of O2 using its molar mass. Now we use the mole ratio, but now it's between O2, which is 7 moles of O2, to 2 moles of C2H6. That's how much gets used up every round. And then we can convert from the moles of C2H6 to grams, which we have that molar mass is 30 grams for 1 mole. And then I'll put that in the calculator and we'll get 2.68 grams of C2H6. Now that's what gets used up, and then we can take that number and say, okay, well, we started with 10 grams of C2H6. We used up 2.68 grams of that C2H6. That means that our excess reactant, that C2H6, after all is said and done, we will still have 7.32 grams of C2H6 left over. And so that is how much excess we have left. So you can see if you take a look here, notice we did the exact same thing, we just did it 3 times. So we started here and we started with the blue, right? And we figured out, okay, if all of the C2H6 got used up, we would get 29.3 grams of CO2. And then we took a look at, so we started with our CO2, and we found out that we would get 29.3 grams. We found out that if we used up all of the 10 grams of oxygen, that would give us this 7.86. And so looking at these two numbers, we realized that this is the one that is smaller, meaning that the O2 had to run out first. And so that's our theoretical yield. That's our limiting. And then we repeated the process again. Notice they're all the same steps. You just have to know where to start and where you're going. So we started it again the third time, and we start with our limiting reactant, which we figured out from the first 2 steps. And now we figure out how much of the excess reactant we ended up using up. And then it's a real simple subtraction problem, right? You know, how much should we start with, how much should we use, and how much is going to be left over. Okay, so then the ending of most of these questions, so just making this a very complete question, is often going to be, what is the percent yield? And so we calculated, all right, so we calculated that we could get 7.86 grams of CO2 from those 10 grams of each of our reactants. That's our theoretical yield. All right, so theoretical yields are always calculated. Now, if in the problem I tell you that you actually get, if you actually get 5.25 grams of CO2, because in the real world things don't completely go exactly as you plan. It's kind of like shopping. There's always tax, so you can't buy quite as much as you would be able to without it. So I could now also ask you if I give you the actual yield, right? So this has to be given, or you're going to measure it in the lab. If that's given, then we could figure out what the percent yield was, because the percent yield is always going to be the actual over the theoretical times 100%. And in this case, if it was 5.25 grams of what we actually got, divide that by that 7.86 grams that we calculated, multiply that by our 100%, and we go to the calculator. And that tells us that we got 60, let's see, we're going to do 3 sig figs. So 66.8% yield. Not a great yield. We prefer to get 80% or above. But for this problem, that's what our percent yield would be.